Combustible dust explosions are a serious risk at many manufacturing, processing, and metalworking plants, and an unprotected dust collection system can be a main cause. An explosion in an unprotected dust collector produces a high pressure wave that can fragment the housing and send heat, flames, and dangerous projectiles into the workplace. This can critically injure personnel and damage equipment and structures. So make sure your dust collector has an effective explosion protection system. The goal of any type of explosion protection equipment is to control an explosion, keep employees safe, and minimize damage. There are two main types of protective systems you can use: active and passive. Active systems, such as chemical isolation and fast-acting valves, react prior to or during a deflagration event. Passive systems react immediately following an event to prevent the deflagration from traveling to other areas and causing more damage. Most manufacturers use passive systems because they are a lot less costly and don't require recertification every 3 months. All passive systems control the speed of explosions by releasing the pressure produced when they have reached a certain limit. Passive systems include explosion venting, flameless venting, explosion isolation, and safety monitoring filters. Explosion venting is the most commonly used passive system. It's designed to safely vent the gases and pressures from a deflagration to minimize damage and injury to workers in the area. NFPA 68 sets the criteria for the design, location, installation, maintenance, and use of these systems. Here's how it works. The dust inside the collector combusts, which increases the pressure inside. The explosion vent releases when the pressure reaches an unsafe level. The vent opens, allowing pressure and flame front to exit to a safe area. Flameless vents can be installed over a standard explosion vent to extinguish the flame front as it exits. This enables the venting to be installed indoors. An isolation valve provides an additional layer of protection. These valves are installed in the inlet ducting to create a mechanical barrier that keeps explosion flame and pressure from traveling through ducts into the process area. Normal airflow keeps the flap plate open, but if an explosion occurs, the pressure wave forces the flap closed, and flames and smoke are contained. An integrated safety monitoring filter, or ISMF, is considered an outlet protection device because it protects the downstream equipment and work areas. Installed on the top of a dust collector, the integrated safety monitoring filter acts as a flame front barrier. In the event of a dust collector explosion, the filter also prevents the flame front from entering the workspace because it contains the fuel, the explosive dust, in the collector. The ISMF is an effective flame front arrestor for ST1 and ST2 dusts according to NFPA mandated design options. These performance-based design options are provided in Chapter 5 of NFPA 654 and NFPA 69. Specifying the correct NFPA-compliant explosion protection technology for your dust collector will minimize personnel injury, equipment damage, and prevent the structural failure of your facility. For more information, call us today or go to camphilapc.com.